Okay, welcome to this important tutorial for chemistry today. So, if you are a chemistry student preparing for JAMB, this is one aspect that requires that you pay very close attention. I don't want this video to be very long, but unfortunately, I cannot help it. So, I will go straight to the point. The topic says Introduction to Stoichiometry. Introduction to what? Stoichiometry. Now, if you are hearing this for the first time, the definition says that stoichiometry is the study of the quantitative relationship between reactant and products in a chemical reaction. So, what we actually call stoichiometry is that anytime you balance a chemical reaction and you try to compare the quantities that so amount was needed to produce so amount, or so and so amount was formed from so and so amount, what you are doing is called stoichiometry. So I want you to know that in chemistry you can use stoichiometry to do many things. Number one, you can use it to determine the amount of a reactant. Now when a reaction happen, certain substances are used up. Those substances that are used up there are called the reactant. And then some substances are produced. They are formed from the chemical reactions. Those ones are what we call the product. So apart from using stoichiometry to know the amount of reactant, you can also use it, as you can see from number 2, that you can use it to know the amount of product that is formed. So very important, I want you to know that stoichiometry is based on the law of conservation of mass. What did I say? Stoichiometry is based on the law of conservation of a mass. I want you to remember that because it's a direct question from JAMB. JAMB has asked a question. Stoichiometry is as a result of what? A, mole ratio. They will ask you different things. But your answer is that stoichiometry is based on the law of conservation of mass. Now, another important thing that I want you to know is that you cannot solve anything in stoichiometry if you don't know how to write and balance what we call chemical equation. If you don't know how to write and balance chemical equation, there is nothing you can do. So if after this video, if you need to carry your chemistry textbook and revise it again, it will be very, very important. Look at how I put it here. I say you must know how to represent a chemical reaction using symbols and formula. When you use symbols and formula to represent a chemical reaction, what you have is called chemical equation. I now say that you should also know how to balance them. You must know how to balance the chemical equation. Let me give you an example. Water. Water contains hydrogen and what? Oxygen. So let's look at this reaction. Hydrogen react with what? Oxygen to give you what? Water. That is simple. But if you look very well, you will realize that this equation is not balanced. The reason is because on the reactant side, which is hydrogen and oxygen, you notice that we have two atoms of hydrogen and two atoms of oxygen. But when you come to the product side, which is water, you will realize that we have two atoms of hydrogen and one atom of what? Oxygen. So oxygen was 2 here, but it is now 1 here. So since the number of oxygen here is not equal to the number of oxygen here, I say that the equation is not what? Balanced. So in order to balance it, we'll say 2 mole of hydrogen plus 1 mole of oxygen, meaning we have 4 atoms of hydrogen and 2 atoms. How did we get the 4? 2 times 2, 4. 4 atoms of hydrogen and 2 atoms of oxygen will now give us 2 mole of water containing 2 times 2, 4 hydrogen. And you see these 2, it affects this oxygen here, meaning we have 4 hydrogen and we have 2 oxygen. So if you count oxygen and hydrogen here and count them on the reactant side, you realize that they are equal. So the equation is balanced. So that is that. Like I said, if you don't know how to balance chemical equation, there is nothing you can do when it comes to mole concept or ratio or something like that. So very quickly, I want you to see this as the steps to stoichiometry calculation. I want to put it so that anytime you are doing any calculation, you can always remember these steps and follow them. So I say steps to what? Stoichiometry calculation. Number one, write a balance equation. Number two, convert given quantities to what? Moles. If they give you mass, change it to mole. And the simple formula for conversion is this. I say use the formula. Amount. This amount now is in mole. Amount in mole is equal to the mass all over the molar mass. Amount in mole is mass all over what? Molar mass. So that is how to convert from mass to what? Amount. Then number three, you are going to use the mole ratio. What I mean by mole ratio, let's come back to this reaction now. For example, now, if you want to know what I mean by mole ratio, you realize that this 2 in front of hydrogen means 2 mole of hydrogen. Then since you can't see any number in front of oxygen, it means there is 1 there. So the mole ratio here now is 2 is to 1 is to 2. So the mole ratio refers to the numbers in front of each of the reacting species, the numbers in front. So in calculating stoichiometry, you really make use of what we call mole ratio. Then after that, you convert to the required unit. What I mean by converting to required unit is that you change whatever you have at the end of the day to what they ask you to calculate. So in case you are still a bit confused, let me give you one example very quickly. Look at this example 1. It says calculate the mass of water. The mass of water produced when 4 gram of hydrogen 4 gram of hydrogen react with excess oxygen. You see that question now? Hydrogen will react with what? Excess oxygen. But you have to find the mass of the water. You are not finding the amount of water. You are not finding the volume of the water. You are finding the what? The mass of the water. I hope that is clear now. You are finding the what? The mass of the water. So the first thing you are going to do is to write step 1. You balance the equation. This is the balanced equation. Then the step 2 now is to convert the quantities to what? Mole. So this N here stands for amount called what? Mole, and it's equal to mass all over what? Molar mass. So if you look carefully, this 4 is the mass, the 4 gram of hydrogen given to us from the question, and then the molar mass of hydrogen is 1. But in the reaction, you notice that hydrogen appear as 2 atoms all the time. So 1 times 2 give us this 2. So if you want to find the number of mole of hydrogen, it is 4 divided by 2 to give us 2 moles of what? Hydrogen. So I now say it implies that 2 mole of hydrogen produced 2 mole of what? Water. How did I know that? Go to the equation. Did you see this? 2 mole of hydrogen produce 2 mole of what? Water. 2 mole of hydrogen produce 2 mole of all right. So now, since we have known that the 2 mole of water of hydrogen produce 2 mole of water, what we are going to do now is to convert the 2 mole of water to mass of water, because the question say what is the mass of water produced. It did not say what is the mole. So we come back to this formula. Amount, which is the number of mole now, is equal to mass all over what? Molar mass. So since we are looking for mass of water, we will make mass the subject. So we say that mass is equal to amount multiplied by molar mass. And then the amount now is what? 2 mole. We multiply it by what now? 18 gram per mole. If you are still wondering, which will give us 36 gram. So the answer is 36 gram of water. But if you are still wondering where this 18 is coming from, 18 is the molar mass of what? water. If you are wondering, let me show you here very quickly. Though this one is not part of the question again, but let me show you. Water is H2O, and don't forget that our mass number of hydrogen is 1, so we'll have 1 times 2 plus oxygen is 16, which is 1 times what? 16, because we have 1 atom of what? Oxygen. That is why we use 1 here, and we have 2 atoms of hydrogen. That is why I use 2 here. So 1 times 2 is 2, and then 1 times 16 is 16. So 16 plus 2 will give me 18 gram per what? Mole as the molar mass of water. That is why I am multiplying it by 2 to get this 36. So this is the simple form of a stoichiometry of what? Reaction. So now I'm going to call this video the first video, stoichiometry part 1, because there are more that you need to learn. So as you watch this video, if you have not subscribed to this YouTube channel, I want you to subscribe. Turn on the notification button, turn it on, so that when I drop the remaining part, you can easily know. Then another thing that can make me drop this, the other part of this video, is when you comment, you like and comment. Tell me in the comment section that you understand what I have done and you are looking forward to know how to solve every other possible problem that will come from here. When I receive such comment from you, I will definitely drop the next video. See you in our next class.